Hi, I'm Kelsey, and I'm an astrophysicist. The universe is unfathomably large. It's made of billions of galaxies, and each of these galaxies has billions of stars. Galaxies also have gas and dust, but there's more. The most massive component of a galaxy is a mysterious ingredient called dark matter, and scientists don't know what that is yet. There's a zoo of different kinds of galaxies, but astronomers break them into three main types: elliptical, spiral, and irregular. Our galaxy, the Milky Way, is a spiral galaxy. It's about 100,000 light years across. What that means is that if you could travel at the speed of light, it would take you 100,000 years to cross the galaxy. We have determined that our sun is located in one of the spiral arms of the Milky Way. We're kind of out in the suburbs. No real pictures of the Milky Way exist. We are far from being able to leave our galaxy and take an actual picture. The word nebula actually comes from the Latin word for cloud, and that's really what a nebula is. It's a giant cloud of dust and gas, mostly hydrogen, out in space. There are competing forces in a nebula. Gravity is pulling things in and pressure is pushing things out. But when gravity is strong enough, the material can become dense and hot enough for hydrogen to fuse into helium. This process is called stellar nucleosynthesis, and it's what gives fuel to the stars to burn. The only information astronomers get from deep space comes from light. To do this, we have lots of different kinds of telescopes. There are visual or optical telescopes, as well as X-ray, radio, gamma ray, and infrared telescopes. The technique astronomers use to get the most information out of light is called spectroscopy. We use spectroscopes, which break light literally into a rainbow of colors, and we can use these colors to individually identify components of light that give us information about the object we're trying to study. One thing about a star that we know is that its mass and age determine how bright it is and the color that it has.
Let's use our sun as an example. As it evolves, both its color and brightness will change.
The Hertzsprung diagram is a great tool that astronomers have used for a long time. To use this tool, you need to know two things. You need to know the luminosity or magnitude or brightness of a star and the temperature or color. When stars are plotted on the Hertzsprung diagram, there are a number of different kinds of groups that emerge. Some of these include the main sequence, the giant and supergiant branches, and also white dwarfs. What it means for a star to be on the main sequence is that it's fusing hydrogen together to form helium in the process of stellar nucleosynthesis. Our sun is currently on the main sequence. It's about halfway through its 10 billion year lifetime. When our sun runs out of hydrogen to fuse, it will eventually start fusing helium. And when it does this, it will turn into a red giant. At this stage in its evolution, it will start creating elements even heavier, like carbon. When the sun runs out of fuel, it will collapse into a white dwarf, which is a very dim but very hot star. A motto with stars is live fast, die young. The more massive a star is, the faster it burns its fuel and the faster it dies. Really massive stars can become supergiants, supernova, neutron stars, and even black holes. The most massive stars can explode in what we call core collapse supernova. This process creates even heavier elements than were originally part of the nebula from which the star was formed. And these elements can go on to form new stars and new solar systems. All of the heavier elements like oxygen, carbon, and iron that we use in our daily lives were once inside of a star. So you are literally made of stardust.
So what have we learned? Galaxies are made up of billions of stars.
Astronomers break them into three main types: elliptical, spiral, and irregular.
Stars form inside nebulae. Telescopes are used to determine properties of galaxies and stars. Stars are classified by magnitude and temperature on the Hertzsprung diagram.
Stars spend most of their lives on something we call the main sequence, where they're fusing hydrogen in their core to create energy and helium.
Our sun, currently on the main sequence, is halfway through its 10 billion year lifetime.
It will eventually become a red giant and then a white dwarf.
Massive stars may explode in a supernova.
And these elements can go on to form new stars and new solar systems.